the last thing we're going to do for this problem is we're just going to go through and approximate the area underneath of the curve. And our curve is going to be this 2x squared plus 1. And we're going to be bound by 5 rectangles, and delta x is going to be 1. All right, so remember our formula for the area. To be able to find the area, that's going to be delta x sub I times f at x sub I. All right, and in this case, x sub I is going to be 3, 4, 5, 6, 7 for our left endpoints. All right. And so this was our diagram that we had before, and we ended up getting an underestimate. So let's just go ahead and figure out what these are going to look like. So I'm going to cut this out. I'm not sure what happened. Just moved it. So pretty close. All right. So let's just get area 1, area 2, area 3. So A1, A2, A3, A4, and then surprisingly A5. And we need 5 because we have 5 rectangles. So it's going to be delta x, and remember delta x sub I is 1 for all of these. Delta x sub I is always going to be the same in all of these Riemann sum problems. Now the function we have is 2x squared plus 1. So this is going to be 2 times 3 squared plus 1. Right? And this one is going to be 2 times 4 squared plus 1. And this is going to be 2 times 5 squared plus 1. And subsequently 2 times 6 squared plus 1. And then finally 2 times 7 squared plus 1. And again, where are we getting all these numbers from? Right here. Okay, so this is our graph. This is our x sub I for our left endpoints. All right, now here's a trick that we can do is we can just go into our calculator, and we know that the first one is going to be 2 times 3 squared plus 1. And then we can just hit second enter, and then we can just change it. Okay, so we can just go back and hit a 4 in there, and then second enter, and do a 5. That way we don't have to worry about making a typo. So I'm going to write these down, 1933.51. And then just 2 more, at least for this one. And then second enter, so we just need 7. So we have 73, and we have and the next one will be easier, by the way, because we can just reuse a lot of these values, 99. All right, so we have 73 and 99. And what is the left area, or what is the area using the left endpoint? So the area is going to be the 19 plus the 33 plus 51 plus 73 plus 99. Okay, so we're just going to add those up really quick. So 19 plus 33 plus 51 plus 73 plus 99. And that's going to give us 275. All right, so our area using the left endpoint is going to be 275 square units, whatever they might be. Okay, and you might remember that this is indeed an underestimate. Okay, so don't forget that this really represents not the exact area, but approximately that area. And we can figure out what the next area is, all right? And then somewhere in the middle between 275 and the upper bound is going to be the true area. All right, so now in this case, our x sub I is going to start at 4, okay, because we're using the right endpoint. So it's going to be 4, 5, 6, 7, and 8. Remember, we have n is equal to 5. And fortunately for us, delta x sub I is going to be 1 each time, all right? We can clearly see that to go from 3 to 4 to 4 to 5 to 6, etc., it's always 1. All right? So We're going to have A1, A2, A3, A4, A5, and then stop there. And the good news is, now remember this one, we're going to start with 4. So that's going to be 1, which is delta x, times 2 times 4 square plus 1. 1 times 2 times 5 square plus 1. 1 times 2 times 6 square plus 1. 1 times 2 times 7 square plus 1. And then mercifully, 1 times 2 times 8 square plus 1. All right, is there any good news? Well, yeah, because if you just scroll up, we already computed 4, 5, 6, and 7 back into the function. Okay, so right here we have 4, 5, 6, and 7. So we have 33, 51, 73, and 99. All right. Now the only thing we have to do is compute 8. So we're going to go into our calculator. We're just going to hit second enter twice. All right, and then we can just go back and just hit a 8 in there, and we get 129. And one last trick, let's just hit second enter twice. And remember this 19? Let's just delete that. And let's just replace it at the end with 129. And we end up with 385. Okay, so we get, now remember this was 129. And then for the right endpoint, the area is going to be 33 plus 51 plus 73 plus 99 plus 129, which was 385 square units, whatever those might be. All right. And again, this is the area from the right endpoint. Remember, the right endpoint provided an overestimate. Okay, we can clearly see that from the graph. Okay, so we go up here and notice right here, there's some overestimate. This is really what's going on the graph here, 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 and here. All right, and just going to get a little more than what's expected. And the true value of the area is somewhere between 275 and 385. So the true area is between 275 and 385 square units. And like I said before, later in the course, we're going to be able to find what that true area is, just not today. So hopefully this gives you a good overview as to what Riemann sums are, how to find the grid points, how to find the change in x, how to find the different areas for the rectangles under the curve to approximate the area, and then finally, how to evaluate the left and right endpoints, being able to identify overestimates and underestimates. We're going to start being able to get the exact areas under the curves. And that's going to be in section 5.2. We start talking about the fundamental theorem of calculus.